Hello and welcome to Manifest Maths. This is the second video on binomial expansion. This is a slightly shorter video. We're going to look at a specific type of question, and there are two more questions of this type on the next page. Okay, so let's start question A. It's quite straightforward, expansion. We've got 1 plus x to the power of 6. So our n value is equal to 6. So we need our coefficients to the power of 6, so we can obtain those in two ways, either using Pascal's triangle or using these parts of the formula here. I'm going to use Pascal's triangle in this case. So that gives us 1, 5, 10, 10, 5, 1, and then 1, 6, 15, 20, 15, 6, and 1. Remembering that we'd have 1, 2, 3, 4, 5, 6, 7 terms in this expansion. Now we only want it up to x to the power 3. So we don't need to do all of the expansion here and find all 7 terms. Our coefficient for the first one is 1. And it's going to be 1 to the power of 6, or just 1. Plus our second coefficient is 6. So it'll be 6x plus 15x squared plus 20x cubed. We could have obviously obtained these coefficients by using these formulas as well. Alright, so for example, if you notice the coefficient of the third term is 15. We used Pascal's triangle to obtain that 15, but we could have used n, which was 6, times by n minus 1, which was 5, over 1 times 2, which would have given us 30 over 2, which would have given us 15. So again, you can pick and choose whether you use Pascal's triangle or the formula method. Now notice that we haven't done the entire expansion here for this. That means that this is an approximation for this term. Okay. Now part B wants us to substitute an appropriate value for x into the expansion to find a value for 0.99 to the power of 6. Okay, so we want to find 0.99 to the power of 6, and we've got an expression for 1 plus x to the power of 6. So what you need to do in this particular case is to understand that to get from 1 to 0.99, x must be equal to minus 0.01. So that's going to be our value that we're going to use in this case. We can prove that by substituting it in. So 1 plus minus 0.01 to the power of 6 would be equal to 1 minus 0.01 to the power of 6, which will be equal to 0.99 to the power of 6. Now, we've already shown that 1 plus x to the power of 6 can be written as 1 plus 6x plus 15x squared plus 20x to the power of 3. So what we're going to do now is we're going to substitute x as minus 0.01 into this. So that gives us 1 plus 6 times by minus 0.01 plus 15 times by minus 0.01 squared plus 20 times by minus 0.01 cubed. The first few terms are quite easy to expand. So if we've got 6 times by minus 0.01, that gives us minus 0.06. The next one, I'm going to do it in 2 steps. We've got minus 0.01 squared, so that becomes a positive quantity. That's why there's a plus sign here. And 0.01 times by 0.01, that's going to give us 0.0001. And then finally, I've written a plus sign here, but obviously if we cube minus 0.001, That's going to give us a negative quantity. This should be a minus 20. And then if we cube 0.01, that's going to give us 0.00000. So 1, 2, 4, 5, 6, 1. Okay? Or 1 millionth. Then it's a case of us completing this calculation. I'm just going to write them all out first. So 0.06. If we multiply 0.0001 by 15, we end up with 0.0015. And then the last one's going to be a negative. So it's going to be 0.00002. Essentially, we're multiplying this 1 here by 20. So the 2 will be in this place value column, which is 1, 2, 5 across. 1, 2, 3, 4, 5. Okay, then we can do this calculation. All right, we can do it step by step if we wish. Okay, so 1 minus 0.06, that gives you 0.94. Then we're adding on 0.0015 and then subtracting 0.00002. Then we wish to add these two together next. So that gives you 0.9415. And then finally we're going to subtract 0.00002 of this value, which gives us a value of 0.94148 as our final answer. Now, if you had this question in an exam, I would always expect you to see if that is an appropriate value for 0.99 to the power of 6. So I would run that through your calculator, okay, and it gives you an actual value of 0.9414814 and so on. And what we notice is the first 5 place value digits match our value here, so we know we're correct. Okay, right, let's have a look at some more questions then. So these are 2 that I'd like you to try. Pause the video. Now you need to be careful when you're selecting your value to substitute in. Okay, so for example, we want to make 1.1 here, so you need to think about what you would add as your x value and substitute in. And then with this one, there's a bit more thinking involved, because once you've done the expansion, there's a fraction involved here. Okay, so pause the video, give yourself 10-15 minutes to try these 2 questions. Okay, so hopefully you had a chance to do the first question. The first part of the expansion is exactly the same as the previous question we did. Okay, so it's the same expansion. We wanted the coefficients for 6, so it's 1, 6, 15 and 20. Again, it was up to the power of x and 3. For the second part, it was a bit more straightforward than our previous one. This time, we were adding on 0.1 to make that 1.1. So you had to substitute 0.1 into the expression that you had, okay, and then do the number crunching. Hopefully you had an answer of 1.77 for that. Okay, again, you could do 1.1 to the power of 6 on your calculator. And it gives you an answer of 1.7715, so it's a very good approximation. And the second question, a bit more going on with this one. Part A was just a basic expansion. You needed your coefficients for to the power of 5, which are 1, 5, 10, 10, 5 and 1. Powers of A decrease every time, powers of B increase every time. Then for part B, write down the first terms of the expansion of 1 plus x to the power of 2 to the power of 5. You wanted the first 4 terms. Now you could have used your first answer for this. 1, 2, 3, 4. Okay, and substitute A as 1 and B as x over 2. Okay, you needed the first 4 terms, so it was 1 plus 5x over 2, 10x squared over 4, 10x cubed over 8, which can be simplified to 1 plus 5x over 2 plus 5x squared over 2 plus 5x to the power of 3 over 4. Now the second part was a bit more difficult, okay? You have to substitute value in to make 1.05 to the power of 5. So to make x over 2 equal to 0.05, which is the extra bit that we needed here, okay? We have to put x over 2 equal to 0.05 and then double the 0.05 to make 0.1. So we were substituting 0.1 again into this question. That was a basic substitution in there, okay, which gave you the values of 1 plus 0.25, 0.025, and 0.00125, and then it was an addition for all of them, which gave you this as your final answer, hopefully. Okay, so we're just going to have a quick look now at this last question, which is the one that was on the first video on sequences and series. Okay, I'm going to give this one a try. Okay, so first of all, in the binomial expansion of 2 minus 5x to the power of 8, find the number of terms. So hopefully you can remember that if you had, something squared, you would end up with 3 terms. Okay, so in this case, so when n was equal to 3 at 2, there was 3 terms. There's always one more the amount of terms than the power. So in this case, there will be 9 terms. The fourth term, we've got to find what the fourth term will be when the expansion is in extending powers of x. Okay, so one method here would be to find Pascal's triangle all the way down to the power of 8 and try and keep this as narrow as possible. Obviously, the further down we go, the wider the triangle is going to get. 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7 and 1, and then the one that we need, 1, 8, 28, 56, 70, 56, 28, 8 and then 1. Let's just check our answer for part A. 1, 2, 3, 4, 5, 8, 9. Okay. Now we want to find the fourth term when the expansion is in ascending powers of x. So for part B, the fourth term will be when it's x to the power of 3. So we're going to come across and find our coefficient. So it'll be 1, 2, 3, 4. So it's going to be 56 times 2 to the power of 5 times by minus 5x to the power of 3. Now remember, so let's just use this as a little teaching point here. We want the fourth term, so the fourth coefficient will be 56. Remember, in this first term, it'll be 2 to the power of 8. The second term will be 2 to the power of 7, to the power of 6, so it's 2 to the power of 5. And remember that the powers must always add up together to give you 8. Okay? Now, there's a bit of number crunching to do here. So we'll have 56 times by 2 to the power of 5, which is 32, times by minus 5 to the power of 3, which would be minus 125 x cubed. So you can imagine this is going to be quite a big coefficient. Okay, so 56 times 32 times by minus 125, which gives you minus 224,000 x cubed. Okay, which is the biggest coefficient we've had by far in any of the questions today. Right then, okay, so part C. we need to find the greatest positive coefficient. Now, if we look at the coefficients across the bottom of Pascal's triangle here, where we've got our 8 and our 9 terms, okay, what we just found out is that this fourth term is a negative 1, okay. The first term, remember, would just be 2 to the power of 8, so that would be a positive. So the pattern is there's going to be positive, negative, positive, negative, and so on, okay. So that last term is going to be positive as well. That's because it'll be minus 5x to the power of 8. And if you raise minus 5 to the power of 8, it'll become a positive quantity. So we suspect that the biggest coefficient here is going to be the middle term, or the 7th term, or possibly the last term. So just to be sure, we're going to find the coefficient for all of them. So for the middle term, it's going to be 70 times by, now because it's the middle term, this is going to be the one term where the power of the 2 is going to be equal to the power of the minus 5x. So that's going to be our calculation for the coefficient, which gives us 70 times by 16 times by 625 x to the power of 4. We can multiply those numbers out. 70 times by 16 times by 625, and that gives you 700,000 x to the power of 4. Right, for this term, the 28, it's going to be 28 times 2 to the power of 2 times by minus 5x to the power of 6, which is going to give us 28 times by 4 times by 15,625 x to the power of 6. So 28 times by 4 times by, and that gives us a massive coefficient of 1,750,000 x to the power of 6. And then finally, our last term, there's going to be no element of 2 in this one, because we're going to 2 to the power of 0, so it's just going to be minus 5. So minus 5x to the power of 8. And if we raise 5 to the power of 8, that gives us 390,625 x to the power of 8. So we can see that the biggest coefficient was from the 6th term, and it was this value here. Okay, now the reason these coefficients are much bigger than the previous questions is because, look, we're starting off with bigger numbers inside the bracket here. We've got 2, we've got minus 5. So when we apply the binomial expansion for those, the coefficients get much bigger. Okay, I hope you found the last 2 videos useful. Alright, that will conclude the sequences and series. All the questions that are in the 2 videos from the last 2 sessions are typical exam questions. Alright, so when it comes to revision, make sure you're practicing these. Try them over and over again. And I'll see you for the next topic on Manifest Maths.